So this is the FLUX sim. So before getting into how we will train the model, it's very important you need to create an environment where this only works with Python 3.10. So I have created my own environment. I'm going to my environment and it's very simple that you need to uh, run Android first. So I need to go to the directory first. Then you need to run app.py. So it automatically opens a browser window there. That will be the web UI in order to train the model. So as you can see, this is the user interface of a Flux gym. And it is very mandatory that you need to have a couple of names which you need to remember while training the model. So first thing is the name of the LoRa, let's say comics, and trigger word, it should be unique one where these will be helpful for a model to trigger whenever you just want to call it. So it should be unique one, let's say comics underscore alert. This is my trigger word, and we are talking about the base models. There are three base models where it will be downloaded automatically when you install the package or the tool. So Dev, it's a licensed one, but it will be helpful for us to train the model with good clarity. And Flux Snell is an open source one and it's free to use. So currently I'm using Flux Dev, where as you can see we have three different VRAMs. So I'll be using 20 GB, where all other settings will be manual, default ones. So each image will be generated like paint for 10 times. If you have a good GPU, then you can increase the size of the training of the images, and epochs will be 16. So as you can see, this is the sample image prompt where you can even write a prompt in order to check the output uh, uh, on the web UI. So let's say Sage doing yoga. So yeah. So before Fluxim, there are a couple of tools like Koya and other ones. So manually, when you are creating that, you need to resize the images. But for Flux, it is not that mandatory. You can directly upload your required images. For now, I'll be uploading couple of images here, where I have extracted it from the PDF. So this is for the demonstration purpose. So I'll be using the 5 or 6. So yeah. So as you can see, the trigger word, it has been added for every image. And now what I'll be doing is like I'll be adding all the comments for the like text for all the images. So Florence 2 is one of the tool or model where it adds uh, image text for all the images. So whenever you have an image and you want to generate a text from that image, then this will be the tool. So it will be taking couple of seconds, and you want to generate the text from it. So after getting the text, what I'll be doing is like I'll be going through each of the current texts. So in order to check how well it has been written, because it's a mandatory process before training the model. If you have like a bunch of images, or like let's say 1,000 or 2,000, then you can go like you can change almost like half of the images in order to get a good results. I guess I haven't trained it, but I'm imagining that it can be done so. So as you can see, all the images text has been generated. So I have uploaded only 6 images. After that, you can just hit the train button, and you can see on the command prompt each and everything is displayed on the logs, where you will be understanding how the process is going. So for the each image, it will be generating almost 16 epochs, and it will be trained 10 times for the each image. So after that, what has an output, what you will be getting is like you'll be getting .safe tensor folder, uh, where it has almost four safe tensor files with different sizes. So I'll be using the base one. I'll be showing you. So after training the model will be generated in the models folder here, and you can so it will generate an output folder. So these are a couple of models which I have trained earlier. So we have seen that I have trained IIT Commerce here. So this will our trigger word. Now let me take the example which I have trained earlier. So this is one of the example, and after training the model, you will be getting .set tensor file. This is the main model, and you need to extract this, and you need to use it in stable diffusion, where I'll be putting through that process as well. So this is a stable diffusion forge where I have downloaded it, and you need to go to that folder and with tab. So this is the Linux machine. So I have used with UI.sh. For people who are using Python. They will have other command like webui.py. So this also opens another browser with different port number. So let's wait. For this also, we need the Python 3.10 in order to get it done. So this is a UI for stable diffusion, and we have the checkpoints here. A lot of checkpoints where I'll be going with in their model for now. Here I have trained it on Snell, but it's okay. We can train it. If you have Snell model, then so this is mandatory that I need to use the level. So let's say Sage, Toon, Blogger, 2, and we need to make sure we need to add Mayora here. So this is the command where you need to use, and you can even change the weightage of my LoRa. So how well you need to have this. So let's say the default size is 0.8 to in order to be in the best region. So after that, you need to hit generate. Yeah, this isn't the best output, but the model it has been trained only with 60 images. Well, for the bigger models, we need to use almost like 3,000 to 5,000 images for better results. So I can even like change the weight size per how. So you can even increase the batch size here. So you'll be getting 2 batches with or 4 different images. and we can even change the model. So for the checkpoints, you need to download it from online, or let's say in case of CVT. So this might take a couple of minutes. Oh, what? See, see. So these are the couple of images it has been generated, and we can increase the quality if it's needed.